where it is going, analyze all different JavaScript thoroughly and identify that. Or what you can do is record traffic while the browsing is going on, styling is going on, and you can identify XML RPC call, REST calls, SOAP calls, JSON calls, etc. So here is like, say for example, as we have taken the case of page flags. So So here is a typical application running in the cloud. So we just take the source, just the client-side code from the save page as. So we say like grab the page. So whatever name is like page. So first thing which we are grabbing the client-side page over here. Now when we grab this page, one of the interesting thing is that we are not just grabbing this HTML content. What we are grabbing is the whole linkage of it as well. What JavaScript they are using, which folder they are in. So everything will come on our local machine at this point. Now we try over here and try to run. So this is like page flags.html has been captured. Now we'll just try to run. For example, we do just the file which we have is a page flags.html, and then the supporting file from that page is a page flags_file. So now we go into that folder and do ls. So now you can see the whole different files have been downloaded. Some of them are JS, some of them are CSS, some of them are JPEG, etc. So we now have all different enumeration, all of the information is with us. Now we just run. We are interested in all JS files because JS file is a file where interfaces are defined. So now we say show me all JS files. So these are the JS files which it has, the list of JS files. So now we start running our algorithms or checks on it and say go into the file and show me all ASMX files. So now these ASMX files you are looking at, these are the backend API calls. All these files. So this is what we are looking at. This is like once you have ASMX, next is you put a question mark WSDL and get their WSDL file. That's the whole discovery would end. So this is the way you can identify the backend piece or backend information which we are looking for. So this is the one way you can identify. Or second is very simple. You just draw with any of the crawlers. Say for example, this is where some of the cloud APIs are used. And they've already published their access point over here. So what we are saying is like crawl the site over here, spider the site, and you can see this particular thing, giving these formats, ASMX. So now you know that this ASMX file is there. So this is the way you can identify, or you can use, for example, you can use the URL graph. Over here, we have a toolkit called scanweb.on. Our site is a Ruby-driven toolkit. You run this on target domain, and you can identify some of the important points. So, for example, this is very important. atlas/trade.smx, which is a backend piece. So now we know that this particular application is running with the Atlas framework, and there is a backend trade.smx application with our web services listed. And actually, first if you want. So this is a different structure which we have over here, which you can use. So now we know that how to access. So now we know that WSDL is there, and the next step which we are looking at is from the WSDL point onwards, how we start accessing those APIs and start testing those APIs. So how we can do that? So those all different stuff will go over a protocol called SOAP. Which is called Simple Access Object Protocol. And in this particular range, there are 3-4 different protocols as well. It's like SOAP is not the only one. There are 3 or 4 different protocols you can use. Invoking object on a remote machine. IO with remote object is XML-based messaging, works over HTTP or HTTPS, and on 2 other protocols. That is why firewall cannot block, and attacks are easy and possible to perform. So this will be a typical SOAP envelope would look like, where your parameter, which is coming from your from your application is something like ID1. Now the rest of the part will be specific with the implementation. So you may have the WS security is implemented, then you may get a different kind of header on a top. But the value which you are interested is ID over here. And you make the call, you get the response back over here. As you can see, this is your response, and then you can start playing around with it. So say for example, so here is our WSDL. We grabbed the WSDL and profiled it. So this is the profile of the WSDL. This is our whole profile. And then you can see over here, we start the listener, and these are the methods available. So now what I have done over here is implemented the whole SOAP proxy in the code. So now if I want to make a SOAP call, it will not go on the wire. I have started the listener over 999. So that will actually not, instead of going on the wire, it will go to my listener. I will grab the traffic, manipulate the traffic, and then I will say go ahead. So now these are the methods which we have. Intro, get product info, get rebate info, and get security token. And we start invoking them. Say for example, if I invoke get product info over here. So this is the actual SOAP. Now this SOAP, this particular SOAP envelope has been created from WSDL in automated fashion. So you don't have to, say for example, a developer wants to implement web services. They don't have to read WSDL, and depending on reading of the code, they have to code their own services. What they say is like all different platforms, be it a J2E or C#, they will say show me your WSDL and I will translate and make a respective call. So they will create their own proxy in between for you. So then what is going to happen is that a cloud API running on Amazon will become your local call. Like if a cloud has a function called a foo and a parameter is a string, then in your code, if you look at the source code, you just write in that foo AB and then say equal to me. So like whatever the output assigned to me, and when that particular call come into the execution, at the back end that particular web services will get called, SOAP will be created, it will hit the server, whatever information comes back will get in place as a function output, and then it will go and get assigned into me. So this is how the backend call will go, and that is where we are interested in. So then we just inject ID equal to 1 and send it. So then we can see over here the finding demo is like whatever little information you have stored on your SOAP API will come back, or whatever little information which is running on simple DB on Amazon will come back to you. So this is how you can invoke it. Once you are done with it, the whole idea is to assess your vulnerabilities. So we now interested in assessing or testing our APIs for security issues or security vulnerabilities. One of the attack vectors is XML poisoning. So XML nodes are manipulated attacks on a passing logic called SAS or DOM. These attacks were very popular 3 years back when all these different frameworks were coming into existence. We used to find these kind of issues. Now we are not able to find these issues because they are already patched or fixed. The second one is a parameter tampering and fault code leakage. So we try to break the web services. Say for example, if a web service is expecting string, we try to send the data as a number. If a web service is expecting number, we try to inject meta character or something like that. That will actually break the backend web services, and we end up getting the fault codes over here. So then you start fuzzing it over here. So say for example, we are doing a parameter tampering over here. So this is a get product info is our SOAP API. Now instead of a 1, I send a $sign, and in the $sign, you can see my response is something like this. There is nothing has come out over here. Now I change it to something else. Instead of a $, how if I send star or double quote, for example. Then I get a 500 internal server error over here. Now this suggests that whatever you injected has done something wrong at the back end, and the whole execution logic has been broken now. And in that error, you can see certain critical information. Now this is the back-end information you are getting: system data, client, connection, etc., etc. It says like there may be issue with the SQL over here. Now all these is a part of a fault code over here. So there is an envelope. This envelope is actually a fault code envelope. Can't show that, but essentially whatever information you are seeing over here would be part of a node called fault code, and the fault code node will have a fault string inside, and that is where this particular information will be sitting. So this is how you can actually identify that, and then next is you start identifying some of the interesting issues with the back-end calls. Let's say, for example, SQL injection. SQL injection can be done using over SOAP or a JSON. One can leverage XP command shell if it's available. So everything which we know about SQL injection, blind SQL injection, etc., can be done over here. Show that demo. Okay, so here is the SQL injection flaw. So once we identify that there is an issue with the SQL client over here, we just do SQL1 and then we go ahead and do, say for example, or 1 equal to 1 and just send that particular information to the target, and that will, instead of fetching one record, it will going to get the records of all others. Now you start seeing this issue with the cloud perspective. So what you're going to get over here is the others data as well, because your SQL injection has been successfully injected into the particular data set. You're supposed to look at the one data set. Instead of that, you are actually looking at some others client database as well. So this is what is happening over SOAP. Or for example, the same thing can happen on JSON as well. So over here, for example, this is our envelope now. This is our JSON envelope, as you can see over here. And then we do a fuzz over here. Now, over here what I've done is, this is a blind SQL injection. So what I'm doing is a 1 or 1 equal to 1, 1 and 1 equal to 1, 1 and 1 equal to 0, and then wait for 10 seconds. So now if I do this, you can see over here, the first two, 1 and 2, 1 is a normal request, 2 and 3 has a 1 and 1 equal to 1 and 1 and 1 equal to 0. Then their page signatures are different, their MD5 hashes are different. So let's say like, there is a blind SQL injection spot at the back. Now over here you can see the response length is 5200, which is very large. It's say like 1 or 1 equal to 1 may be executed successfully. And finally you can see over here the response time is 10 milliseconds over here. Because I have injected, wait for 10 seconds. So like my execution over API was successful and actual execution stopped for 10 seconds before it's going further. So these are some of the tricks by which you can identify what is wrong with the API calls. Okay. Another attack vector is XPath injection. XPath is a new way of querying XML document, and XPath query crafting is the next generation attack methods we have over here. Now, XPath is going into a little detail of XPath. XPath is essentially like we do a select statement against our database. What you can do is you can write XPath query where say like if my XML document has /motor/ say for example /car/ color equal to red, then give it, because your XML document is a large. Now you need to do a node-based query, right? So that's where the XPath is going to be executed. Now over here, for example, if you do XPath injection, so over here in this particular case, so web services are using a lot of different XPath mechanisms at the back end. So say for example, we do a get security token, we pass on my username and password over here, Shreeraj, and say for example, Shreeraj. Okay, so here is I have passed my username and password credential. And say, I got my security token over here, a small token which I got. Now I've injected this XPath parameter. You can see over here, this is my X path.